In this video, we are going to find the maximum value of the expression xy times 1 minus x minus y, all divided by x plus y times 1 minus x times 1 minus y, where x and y are real numbers between 0 and 1. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. There is a very simple trick that can help us solve this problem very quickly. In fact, we can just let z equals 1 minus x minus y, then the expression becomes xy times z, all divided by x plus y, all divided by 1 minus x, and I can call that z plus y, and for 1 minus y, I can call that z plus x. So the expression becomes much neater. Now, I'm going to divide into two cases. The first case is that z is a positive real number. In this case, it's actually easy, because to find this maximum value, I'm going to try to minimize the denominator instead. Notice that I can say x plus y is always larger than or equal to 2 times square root of xy. This is either due to the AM-GM inequality, which says for any n positive real numbers, the arithmetic mean is always larger than or equal to their geometric mean. Or I can just say this is because I can move 2 root xy to the other side, and the left side can be factorized as square root x minus square root y all squared, and we have this perfect square to be always non-negative. So this holds. Now from this we can use a similar argument and say that y plus z is larger than or equal to 2 root yz, while z plus x is larger than or equal to 2 root zx. So multiplying the product is larger than or equal to 8 times square root of x squared, y squared, z squared, and that's exactly 8xyz. So therefore, xyz divided by the product of the other three terms is at most 1 over 8. So in this case, when z is positive, the maximum value of this expression is 1 over 8. Now, the other possible case is that z is not positive, or I should say is at most equal to 0. Then either z equals 0, then xyz over x plus y times y plus z times z plus x will be equal to 0. This is because the numerator is 0, and for z plus x is equal to x, this is equal to y, and for x plus y is positive. X and y are also positive, so denominator is not equal to 0. So that means the whole fraction equals 0. Or z is negative, then the same expression can actually be rewritten back into the original version just for the bottom part. For y plus z, I'm going to rewrite that as y minus x back to the original version. Then since x and y are less than 1, that means this is positive. X and y are positive, so the sum is also positive. xy is also positive, but z is negative. So altogether, this fraction has to be negative. Now from these two small cases, we know that they cannot compare with the first case, which gives the maximum value to be 1/8. So that means 1/8 is the final answer. Just one more question. Now we know that 1/8 is the maximum value. So when will we attain this maximum value? The answer is we will attain that when we have equality to happen on all of these three inequalities. And we know that this can only happen, say, for the first inequality when x equals y, for the second inequality when y equals z, and for the third inequality when z equals x. So altogether, that means we need x equals y equals z. But z is equal to 1 minus x minus y, so that means the sum is equal to 1. And all of these three unknowns have to be equal when the maximum value is attained. So that means equality holds when all three unknowns are equal to all. It's just x and y because z is made up by ourselves. So x and y are both equal to 1/3. Please feel free to share ideas in the comments. Thank you for watching. See you next time.